Line segment joining the midpoints of any two sides of a triangle is parallel to the third side and is equal to half of it. So this is a midpoint theorem. Let us prove this theorem. First, let us draw a triangle, okay? So this is a triangle. This is A, this is B, and this is C. Now, let us consider this is the midpoint of side AB, okay? Let us name this as point D. And this is the midpoint of side AC. Let us name this point as E, okay? Given D and E are the midpoints of sides AB and AC respectively of triangle ABC. Okay, D and E are the midpoints of sides AB and AC of triangle ABC. Okay, D is the midpoint of side AB and E is the midpoint of side AC. D and E are joined. Let us join this point D and E. Okay. Now we are asked to prove DE is parallel to BC and DE is equal to half of the length of BC. Okay. So to prove number one, DE is parallel to BC. DE is parallel to BC. And number two, DE equal to half of the length of BC. The length of DE is equal to half of the length of BC. Suppose if BC is 20 centimeter, then length of DE is half of 20, that is 10. If BC is 10 centimeter, then the length of DE is half of 10, that is 5 centimeter. Okay, DE is half of BC. Construction, let us do construction. Okay, now let us extend this line segment DE up to the point F, okay, such that DE and EF are equal. Length of DE is equal to the length of EF. Okay, DE is extended up to F such that DE equal to EF. DE and EF are equal. And let us join C and F also. Okay, C and F are joined such that CF is parallel to BD. CF is parallel to BD. And C and F are joined such that CF parallel to BD. Okay, now proof. We can see two triangles here, triangle ADE and triangle ECF. Okay, our first task is to prove these two triangles, triangle ADE and triangle ECF are congruent triangles. Okay, so in triangle ADE and triangle ECF, we have DE and EF equal, isn't it? DE equal to EF. This is by construction. This is by construction, isn't it? DE and EF are equal by construction. DE equal to EF. And we have these two sides are equal. Okay, DE and EF. Side DE of triangle ADE and side EF of triangle ECF are equal. And we have this angle. angle AED and this angle CEF equal angle AED equal to angle CEF. These two angles are equal because they are vertically opposite angles, isn't it? Vertically opposite angles. Vertically opposite angles. Okay, suppose if we have two lines intersecting at this point, then we can say this angle and this angle are vertically opposite. Okay, so these two angles must be equal to each other. If this is 30 degree, this angle must also be equal to 30 degree. Similarly, these two angles are vertically opposite and equal to each other. Now, and we have AE, side AE of triangle ADE and side EC of triangle ECF are equal. Side AE equal to side EC or CE. Okay, side AE and EC equal because this is given to us. This is given. E is the midpoint of side AC, isn't it? E is the midpoint of AC. Since E is the midpoint of AC, so we can say AE is equal to EC. Now let us see two triangles here. Okay, so we have two triangles here. In these two triangles, if this side is equal to this side, okay, like this side is equal to this side, and if this side is equal to this side, like this side of triangle AED and this side of triangle CEF, these two sides are equal. And if this angle is equal to this angle, like this angle is equal to this angle, then we can say these two triangles are congruent to each other. Okay, they are congruent to each other. If these two triangles are congruent to each other, then what does that mean? If we lift this triangle and place over this triangle, these two triangles will completely overlap each other. Okay, so their corresponding sides will also be equal to each other. This means this corresponding sides will also be equal to each other. Side AD of triangle ADE and side CF of triangle ECF will also be equal. Now, therefore, we can say triangle ADE is congruent to triangle ECF because side angle side congruency criteria is fulfilled. Side angle side angle side all are equal to each other, isn't it? Side, this side and this side equal, this angle and this angle equal, and this side and this side equal. Side angle side criteria is fulfilled. Side angle side is fulfilled. So triangle AD is congruent to triangle ECF. Okay, this means their corresponding side will also be equal. Side AD will be equal to side CF, isn't it? But we have AD is equal to BD, isn't it? But AD equal to BD. Why? Because D is the midpoint of side AB. So if D is the midpoint of AB, we can say AD is equal to BD. Since this is given, okay, D is the midpoint of AB, isn't it? Now from these two equations, AD equal to CF and AD equal to BD, AD same thing. This means CF equal to BD, isn't it? Therefore we can say CF equal to BD. Okay, this CF and BD are equal. And we also say, and CF is parallel to BD. We have in construction CF is parallel to BD. So CF and BD are parallel to each other, and CF and BD are equal to each other. This means we can say BCFD, this quadrilateral BCFD is a parallelogram, isn't it? Because opposite sides are equal and parallel. If opposite sides are equal and parallel, then that quadrilateral is called parallelogram, isn't it? So BCFD is a parallelogram because the opposite sides CF and BD are equal and parallel to each other. So we can say BCFD is a parallelogram. That means DF and BC must be parallel to each other because these two sides are opposite sides of parallelogram, isn't it? Therefore we can say DF is parallel to BC because opposite sides of parallelogram are parallel. Okay, DF and BC are the opposite sides of parallelogram BCFD. So DF must be parallel to BC. And so DE is parallel to BC because DE is the part of DF, isn't it? So we can say DE parallel to BC. If DF is parallel to BC, then we can say DE is also parallel to BC. So number 1 is proved. We were asked to prove DE parallel to BC, isn't it? DE parallel to BC. So DE is parallel to BC. Now DF is equal to BC, isn't it? DF equal to BC, we can say this. DF and BC are equal to each other because opposite sides of parallelogram are equal to each other. Opposite sides of parallelogram are equal to each other, isn't it? Each other. So we can say DF is equal to BC. But DF is equal to DE plus EF. DE plus EF will give us DF, isn't it? So instead of DF we can write DE plus EF. DE plus EF equal to BC. Or we can write DE plus DE. EF and DE are equal. EF and DE equal by construction, isn't it? DE and EF are equal. DE and EF are equal. So instead of EF I am writing DE. This DE we have here, and instead of this EF I am writing DE because DE and EF are equal by construction. So DE plus DE equal to BC. This will give us 2DE equal to BC, or therefore we can say DE equal to, this 2 will go to the denominator by cross multiplication, isn't it? So BC, D equal to half of BC. So this is also proved. Number 2 proved. Okay, this is number 1. DE is parallel to BC and DE is equal to half of BC. DE is parallel to BC and DE is equal to half of BC.